Hello everyone and welcome to this video. Now in true Christmas spirit, I'm going to be continuing the tutorial videos that I've been working on, and in this video we're going to be taking a look at pivots only. So this tutorial is for pivots. Later on I could look at the tracks and connectors, all that stuff. Here we're looking at pivots, hinges, that type of thing. So this is intended for beginners. If you are an advanced or intermediate player, you may watch just to learn or for entertainment value, but this is intended for beginner level users. So as you can see here on this tray behind us, we have the different types of pivots laid out for us, and I'm going to go through each one and explain how you can get it working. So first things first, when we type in pivot on our component inventory search, you get a variety of different types of pivots, and if you don't know what you're doing, they can be kind of daunting, especially if you are just starting off in the game. Having a slanted instrument panel like you see here, that is using pivots. I had a question today, and I've had other questions before, and I had the question myself when I just started the game. How on earth did people get something slanted in a game that just has kind of blocks and pyramid and angular shaped pieces? So how do you get something like this? The answer is pivots. So we're going to go through them one by one in order what I believe is the easiest to the most complex. So the first thing you have to do is have an understanding of the game bodies. If you don't know this, check out my video for just basic introduction into Stormworks. You have to know what the different bodies are, so you see the different colors on each of these pivots. Pivots rely on creating one or more bodies. So long story short, a body is an interactable and movable piece of the game. They can interact with each other. They're not attached, call it fixed to each other, but rather have some movement. So that's a shorthand explanation. So if you add something here, it is on a different color, it is a different body. Okay, moving forward, this pivot here is your basic pivot. It literally just called a pivot, and it says a basic pivot can move freely. It can rotate 0.5 turns in both directions. So what that means is there's not even electricity, there's nothing through this. It is pretty much a basic dumb element, if you want to call it that you can move freely, as we're going to demonstrate right now. So here it is, and as we walk here, we can move it, and it moves to 0.25. So we're kind of hitting it now. It's not quite, it's 0.25. On this side, we can get it to 0.25, even a little bit more, you could see. So it's this would be 0.25, and then it goes to like, it looks like 3. Anyways, this is a fully free moving hinge piece. Call it like your door, almost like if you look at your door, this is what a door hinge looks like, and it just moves freely on its pivot point. The other ones are more intricate than that for sure. So this one is good on applications where you just need something to fall into place and be dropped there. A good example of that is this tow truck arm. You could see that the pivot is right here, and then we got this green piece attached to here, and as we spawn it, this is going to drop into place pretty much instantaneously, and it then attaches with this spring or piston, but that just freely moved and there was nothing more to it than that. So it's a fully, call it gravity or movement based application. Okay, we've covered the first one here, so we're happy with that. Now on to the rest of them. Now the rest of them all have logic components, and they all have electrical components. So we are going to put a battery first, because all of them have to be connected to electricity, and I'm going to just go ahead and connect the node. It'll help us in the future. Now these next two little ones here, and the reason why they're little is because they're called compact. So compared to these other ones that are bigger, these are compact. And what's nice about them is they're small. What's not nice about them is they don't have as much power as the big ones. If you look here, we got 200 motor, this one's 100 motor, and then here we get a 200 motor, 200 motor, and 1000 motor. So this is the strongest one, is this velocity pivot. These two actually are the same as this, which may have been an update. I don't recall this being the case before. Anyways, What we want to do is these compact pivots cannot transfer any fluid. As you can see here, we can actually transfer power or transfer fluid. These ones are just pivots, nothing else to them. This is what I use for my dashboard leaning process. So what I'm going to do is, for visual purposes, I'm just going to add a little arm up here that's going to be spinning around, and I'm going to add the same thing on this one, just a little bit higher so they don't interact with each other. And this is going to explain to you the difference. So what I'm going to do is put a throttle lever, and the reason I'm doing this is just because this is the simplest way to demonstrate this. And what I'm going to do is allow it to go in the positive and negative direction, and going to collect its electricity, and I'm actually going to attach it to both of them just so you see exactly the difference, because this difference is going to be the instrumental key to understanding why they are two different things. So if I turn this throttle up, this one here is going to position itself at a target rotation. So whatever I put here, this is going to match in rotation. This one is going to match it via speed. So if I turn this, there we go. So this throttle lever is 50 or 0.5. This is moved to 0.5. This is going at a speed of 0.5. Okay, that factor is the most important. So in theory, this one can make a full circle where this one can't. And if I put this to 1, this is the maximum amount that the compact robotic pivot can rotate. It can only rotate 90 degrees. So if I pull this back down to 0, this is where it started, and this is where it went. So it rotates 90 degrees in this direction and 90 degrees in this direction. Whereas this guy will freely spin full circles at the speed you set it to. Okay? So that's the key difference. Now, my personal preference is this one because you can control it in a dashboard-like situation or in a door, for example. So this red one is where our simple door microcontroller comes in. I've explained this one in other videos. I explained it in the door video. All it is a numerical switch box with a button and a property number for the off and on position. So when it's off, it does this, 0. When it's on, it goes to 1, and you attach to your pivot. Super easy controller. This is one of the first ones you should probably have in your workbench. And what you do is you press door open amount, close amount, and all you do is attach this to the pivot. And then you have to have a button, and with the button, all you do is attach the button here and make sure the button is attached to the battery, and you're off to the races. You can now press this button and this will rotate to the position of 1, which will be 90 degrees in the positive direction. You see the arrow here? This is going to rotate and it'll be facing like that. So that is with this microcontroller, and we're going to demonstrate it. Now this one is different. If you take this exact same piece here, what you're actually going to end up doing is attaching this button to here, this to here, and if we press this, which we're going to do, you're going to see it's just going to use the speed, and it's going to pretty much set the speed to it and going to go. So this one here is a door, right? Door open, door closed. This one, spin at this speed or stop. Spin at this speed or stop. So for the red one, we're done. This is how you'd, for example, put an instrument panel at an angle, and all you do is you'd put your pivot as such, and then you'd put your instrument panel or whatever like this, and then you want it to be, say, at a value of, let's go 0.4. Let's not go, because we don't want to make it flat. That's not the intention. We want to make it at an angle. So if we spawn this in and press the button, you're just going to see this is going to go to 0.4. So that's a nice slanted instrument panel angle that you have here. And you don't need or don't want to put it in a microcontroller like this. But what you want to do is just have a constant. Alright, constant number. This guy here, constant number. And then you hide this controller somewhere, and all you do is attach it to here and put this to be like we had 0.4. And that will now automatically, as soon as you spawn, it rotates it to 0.4. And that's all you have to have in your ship. You don't have to do anything other than that, because it's automatically going to always stay in that exact same locked position. So work done covering this one here, because that's pretty much what there is to it. You have this button and this controller, and you can set it. Now this one here, like what we did, we set the speed, but say I don't want to set the speed. Say I also want to set the rotation on it. You cannot set this one to act like this one. All you can do with this micro one, at best, is have it rotate at a speed. And I did this intentionally because that's where it differs from the large pivots, which we're going to look at here, and these ones. So these small ones, call it, are dumb with quotation marks around, like I'm doing the little finger thing, because all they do is spin. So this one will either set it to a rotate, this one will either spin. You cannot have it do anything other than that. Alright, so this controller, sure, you can press it and all it's going to do is spin at a speed we want it to. But that brings me now to this. So if we drag this same one we were just working on, but if we drag it to the velocity pivot, which we have here, and I'm going to jump ahead of these ones just for a second because I do want to show you that difference. So with a good microcontroller, we can make the velocity pivot function the same way as a robotic pivot, meaning it won't spin hundreds million circles forever, but rather stop at a position we want it to. And how exactly we can do that is if we start off with the previous microcontroller that we built, which is a simple numerical switch box that has a button controlling the door open and door closed amount, and it controls the pivot. So this is the same microcontroller we used for the earlier pivot, except we have to extend this out and add a PID controller. Now, if you're not familiar with how PID controller works, I strongly recommend you look on the internet, but a very basic breakdown of it is pretty much it has three inputs. Sorry, it has, well, three inputs, but two number inputs, a set point, a process variable, and it has one output, a control output. So the control output is obviously going to go to this pivot, except this pivot is now going to be pivot speed. And we have to add one more node, which will be a number input, and that's going to be our rotation. Okay, so with the pivot speed and the rotation added, what we now do is figure out where to attach them. So the way that a PID controller works is it utilizes whatever you put as a set point and tries to make your process variable match it by adjusting this control output. So that's the easiest way to explain it. So we want the set point to be our door open amount when we press this button, and by adjusting the velocity of the thing, or the pivot speed, we're trying to make the rotation match that amount. And now this active button, we could link it to here, but that will not work in the case of the door being closed. If we set this to -1, this won't work. So what I recommend is have a constant on, and it will eat your battery, so be careful, but pretty much constant on. And now you have these three numbers here. This is where the tough part about PIDs comes. You have to do a lot of trial and error. So there's internet sites and videos about how to tune this. We're just going to set 1 for now, and you'll see that how it works. So as long as you set the proportional gain to 1 and spawn this in, and then attach speed to speed, rotation to rotation, and we will need a button, and this button will attach to here, and everything attaches to electricity. So if we spawn this in and take a look at how it works, it rotated itself to 1. Now I do want to put a little arm so it's easier to see, so like that, except you saw that it made almost a full circle. So what I would recommend, if you want to match what the regular pivots do, is 1 will make a full 360 circles. So you actually want 0.25. Now if you put 0.25 and press this, you're going to get the exact same thing we got over here with the robotic pivot. So we press this and it goes to 0.25. You turn it off and it closes. So this is pretty much the best way to make this type of thing work. Now the nice thing about velocity pivot, this one specifically, not only is it much stronger, which obviously is a huge benefit to these guys, but also if you move it, like say you attach a lot of weight, or say I run into it, this will actually affect it. Me moving or running into it affects this, but then this wants to counteract what I'm doing to it. Whereas if you run into this one here, say you do this and run into it, it is a little more stable, but it will move with enough load. So what will happen if you run into this one is it will just give. It won't do anything, whereas this one is actually going to fight you back to try to go back to that original spot. And it's stronger to begin with. So this one has a clear advantage for that reason. Call it this velocity pivot. And now on to the last two here, which are pretty much the same thing. They're exactly the same. They have input rotation and they have rotation target being outputted. So that's all there is, the two nodes. And the difference, like I said, one of them transfers power. So you can actually have, say, an engine on this end of the ship, and then you could attach a propeller, just as a basic example. I know that's not an engine, that's a generator. We could put motor here. And now, of course, that would be useless, but what if you were to do this and then have your propeller? You can actually steer the ship by doing this. So if you move these around, power goes through here. So this is your engine to your propellers, and you could move them around. So that's the advantage of this one. This one is what I use for my cranes that drop liquid, like my oil crane on the Alta tanker uses this style pivot, because you could actually move this arm and still transmit water or fluid or gas or diesel, whatever, through it. So that's the advantage of this one. Now, as far as the rotation target and this thing's concerned, current rotation, all you do is you need the exact same microcontroller that we used on the small rotation pivot, or small compact robotic pivot, because these ones don't act by speed. All they do is act by the rotation target. So as long as you have a target set, so either form of a button or the form of a throttle or the form of a seat, like this is where the possibilities are truly endless. You can have all of these things and you can have them attached to any of this. So that's where these types of things come into play. And all you have to then do is hop into your seat or hop into your throttle and whatever, and you can get these to move. So it's not, these ones are fairly simple, except for the fact that they transmit fluids. So the hardest one is this one here, because you want to have a special microcontroller that can set it to positions. And this one, which is a speed one, isn't complicated because you can't really do much with it other than, say, put a radar on it or a searchlight or spotlight, something that just moves around constantly in a circle, like just at a constant speed. That's good for this. These ones are good for a lot of other stuff. Now, of course, there's tons of applications for all of these, so please don't comment, oh, you could use this for this and you should have mentioned this. Like, yes, there's millions of different things you can do, but as a basic gist of what this game allows, if we hop into this seat, I'm moving it now just by pressing A and D. Whereas the other one, I believe I put on this throttle, so you could do that, or you could press the button and have it move. This one I disconnected, or this one I messed up with the PID. So lots of different ways you could do things, or you just have your basic one you could just kick around. But this is a basic tutorial on all the types of pivots. The one I didn't cover actually are the hinges, which are technically also pivots. We got the two types. We got the robotic door hinge or the robotic hinge. Now the door hinge is what you use to actually make a door, so the door framing piece goes on it, whereas this one actually transmits both fluid and RPS, so you can transmit different things. And what they do, if you put them onto power, is you simply turn the lever and control them. So these ones are like pretty much the same as your robotic pivots. They just move to a certain extent. They don't have the, call it a constant range, they just have the 0.25 turns in both directions. But one interesting thing worth noting is if you have them all attached to power such that you could cut power to it, or if you just don't even bother attaching them to a power source, like say we have here a pole, and then we're going to put this pivot, and this is like, call it a flag on the back of our ship. So this one's not even attached to power, and it's a compact velocity pivot. On the other hand, we're going to take a compact robotic pivot and have it not attached to power, just for comparisons. And let's actually give it a flag color. So this one can be orange, and this one here can be blue. So if I spawn this in, look at that. So what we learn is the compact velocity pivot with no electricity will freely spin. It will freely spin, whereas a compact robotic pivot with no electricity will not freely spin. So as you can see here, we turn all these buttons. If we turn the breaker off here, this one we can interact with and push however we want, whereas this one we can't. And likewise for these here, robotic pivots, we cannot move them, whereas this one here, we can move. So if it's not attached to electricity, it pretty much spins freely, just like a ball bearing, whereas these ones are not allowing any movement if there's no electricity. And then of course, if you turn electricity on, this has to reset itself back to its original position, and this is just continuing off where we left it to be going at that speed. But there you have it. So this is very brief, but hopefully detailed enough little tutorial on how to use pivots in Stormworks. Give me a like if you appreciated this video. Drop a comment if you have something to say. I always like to hear from everyone. Thank you to the Discord community for actually suggesting this video. So hopefully this is useful to some users. And as always, happy Stormworksing, everyone.